Number 1, you're supposed to evaluate this. Since you're dividing and they have the same base, you can use the quotient rule, which means you subtract the exponents, top minus bottom. Our exponents have common denominators, so you just subtract the numerators. 5 minus 3 is 2. Leave the bottom the same. 2/4 reduces to a half. That's the same thing as the square root of 64, which is 8. Number 2, express using rational exponents. Take the exponent, put that in the numerator, put the root, put it as the denominator. 18's exponent is 1, the root is 5. X's exponent is 3, the root is 5. Y's exponent is 15, the root is 5. If any of your fractions reduce, do so. 15/5 reduces to 3. Number 3, express using radicals. Our exponents need to have common denominators. 1/3 and 1/4 have a common denominator of 12. So you multiply the third top and bottom times 4, multiply the fourth top and bottom by 3. Any integers, any numbers such as 15, do not put inside the radical. Once you have common denominators, make the root the denominator, and then the previous numerators will become the sole exponents. Number 4, using the power of a power property, multiply exponents. A has an exponent of 1. A times a fifth is 1/5. 5 also had an exponent of 1. 1 times a fifth is a fifth. C had an exponent of 1. 1 times a fifth is a fifth. 10 times a fifth is 10/5. 15 times a fifth is 15/5. Notice I did not reduce my fractions, not till the end. Using the product rule, they have the same base, add the exponents. A has exponents of 1/5 and 10/5, that's 11/5. C has exponents of 1/5 and 15/5. Adding it, you get 16/5. None of those reduce, so we are finished. 5 and 6, 7 and 8 using calculators. I'll have another video up for that. Number 9, write each equation in logarithmic form. This will be log base 5 of 125 equals 3. This is the pattern you just have to be able to follow. Base becomes the base, exponent becomes by itself. What was by itself becomes the argument. Number 10, write each equation in exponential form. Our base is 9, our exponent is 3/2, equals 27. Number 11, evaluate the expression. I would like to use log identity number 1, which says if I have a log with a base and my argument has the same base, the answer is the exponent. So if I can make 2 to an exponent equals 64, then I win, just like Charlie Sheen. It's to the 6th. Therefore, log ID number 1 gives me 6. Number 12, evaluate the expression. Same concept. I want to get 1 divided by 343 to have a base of 7. 7 cubed is 343. Since this is 1 divided by 343, it's the reciprocal of that. To get the reciprocal, you make the exponent negative. This is 7 to the negative 1/3. Once again, 7 to the 3rd is 343. And since it's a negative exponent, it reciprocates at 1 over 343. Therefore, this is just negative 3. Number 13, evaluate the expression. Once again, I want to get the bases to be the same. 2 to the negative 4 is 1/16. Therefore, it's negative 4. Number 14, using log ID number 2, I want this to say 13 to the log base 13 of something. To accomplish that, I need the 5 moved. Using the power property, I can move that 5, which was a coefficient, to an exponent of the argument. 2 to the 5th is 32. Log ID number 2 tells me then this is just 32. Solving the equation, what I would like is I would like the left side to have just one logarithm, not 2. Using the product rule, I can multiply the argument of 2x and the 10 and get 20x. Then I can use the property of equality to say that the left argument equals the right argument. solve for x. This is 37/10, or if you prefer, 3.7. Number 16, I want it to be the same way as number 15. I want it to just be log base 7 of something plus log base 7 of something. To accomplish that, use the power rule with the coefficient of logarithm to be the argument in both those first two terms. 5 cubed is 125, 3 to the 4th is 81. Now using the product property, since I'm adding logarithms, I multiply my arguments. Therefore, x is 10,125. Graph the inequality. I know what the parent graph looks like. It has a horizontal asymptote at y equals 0. I know that this minus 4 translates the graph to the right 4. So instead of crossing at the y-axis at 1, so instead of being a point at 0, 1, it's a point at 4, 1. So I got my horizontal asymptote, I draw my curve. My point that was 0, 1 is now 4, 1, because that 4 moved it to the right. And then I shade below, since it says less than or equal to. Number 17, it says y is less than, so it's a dashed curve. The parent for this has a vertical asymptote at x equals 0, crosses the x-axis at 1. This has not been moved at all, so it's still going to cross at 1. And it's shaded below, since it says y is less than. Number 19 says use a calculator. I didn't. It's the same as the parent, has a horizontal asymptote at y equals 0, crosses the y-axis at 1. There's no shading involved. When is it increasing? Well, it's always increasing. As you go left to right, it goes up. That's what it means to be increasing. When is it going up as you go left to right? So it's from negative infinity to infinity. When is it decreasing? It's decreasing never, because it's never going down. Number 20. For this problem, you need to use the future value formula. You know that because it says how much will his account be worth when he retires in the future. It tells you he's making $2,000 payments. He's going to do it for 30 years at 8% interest, and he's making one payment a year. It's all in the problem. You plug these numbers in. The numbers for this problem are pretty simple. 0.08 divided by 1 is 0.08. Add that to 1, you get 1.08. 1 times 30 is 30. To simplify this, if you pull that 0.08 out to the front, so you get 2,000 divided by 0.08, you're going to get 25,000. What's left in the parentheses is 1.08 to the 30th minus 1. Put that whole thing in your calculator. You get $226,566.42. 21, since this says compounded continuously, it's a compound interest formula. It's important to note the 6% should be a decimal, 0.06, and at the time, it's supposed to be in years. 5 6/12 is 5.5, which is 5.5 years. 0.06 times 5.5 is 0.33. There's no rounding there. Put the rest in your calculator and round it to the nearest cent. You get $2,781.94. 22. We're going to say x is the number of times it's going to double. So our total time is going to be 5 times x, because it says it doubles every 5 minutes. We start out with 50. It's going to double. How many times? We don't know. So it's going to be times 2, times 2, times 2, times 2. We don't know how many 2's there are. That's why there's an x there. We're going to keep doubling it until we get 12,800. If you divide both sides by 50, you get 2x equals 256. 256 you can write as 2 to the 8th. Therefore, x is 8. It doubles 8 times. So how much time does that take? 5 minutes times 8 times is 40 minutes. 23, we got this wonderful formula that tells us the pH of Mountain Dew is 6.2. So you plug that in, trying to get h by itself, anti-log both sides, gets rid of the logarithm on the right. Anti-log and log are inverses. Then if you multiply both sides by h plus, it gets rid of your fraction. And to further get h by itself, divide both sides by anti-log of 6.2. Remember, anti-log of 6.2 means 10 to the 6.2. Put that in your calculator. Gives you that answer, which in scientific notation is 6.3 times 10 to the negative 7th.